Okay, so in this video, let's just talk about eigenvectors and eigenvalues. So we have something like this that technically looks like this. Now here, x will be our eigenvector, and then lambda will be our eigenvalue there. And where a it's like a matrix. Remember, this is just the eigenvalue, and then x will be our eigenvector. This one will be a vector. Now, remember, keep in mind that if you equate this to 0, then you basically have ax minus lambda x. This will be equals to 0. And now if you want to factor by x, you'll have x. And now since A is a matrix, you have to subtract lambda multiplied by the identity of matrix A, which technically means something here, which means that A must be a square matrix in order to do that. Now, x cannot be equals to 0. You should just keep that in mind, because if it's 0, it doesn't really tell us anything. Remember, it's our eigenvector there. So now, how do we find the eigenvector and the eigenvalue for a matrix? Let's say probably we have a matrix. Let's say we have a matrix. Let's say matrix 1. That is the entries 1. Let's say 2, and then 4, and then 3. Let's say we have matrix A, and we're looking for the eigenvector and the eigenvalue for matrix A, or the eigenvalues associated with matrix A, and its eigenvector associated with that eigenvalue. Okay, now what we're going to do is like rewrite that in argumented matrix form. So remember, like 1, 2, 4, 3, that's going to be like a 2 by 2 matrix there. So that means you'll have x1 and x2, and then you have an equal sign lambda, and then you have x1, x2. So, and then you further proceed there, you just simplify this, go back to writing this in a linear form, a linear equation. So that means you'll have 1x1, which is just x1, 2x2, which is just going to be 2x2, and it's positive. And this will be equals to multiply this inside, then you'll have lambda x1. So now when you have something like this, you can take this that side, and then when you take this that side, then you basically have like you factor by x1, so you basically have 1 minus lambda x1 plus 2x2 equals to 0. So now, when you have this equation here, remember you also have a second equation here, 4x2. Then you have 4x2. Let me just mark this one to be 1. And then you have 4x2 plus, 4x1. Sorry, this one is associated with x1. And then you have 3x2. This will be equals to lambda x2. And this, okay. Then we further simplify this, and then we have 4x1 plus 3 minus lambda if you factor by x2, and then you have x2 equals to 0, and this will be your second equation. So now you have these things, and now you want to solve for lambda. Obviously, when you do that, you just equate the determinant to be 0, of the determinant associated with this to be 0. So that means like 1 minus lambda, 2, 4, 3 minus lambda there. And then this will be equals to 0. You're basically taking the coefficients like this, 1 minus lambda and 4. These ones are associated with x1, and this ones are associated with x2. And now you want to find the value of lambda, the eigenvalue there. So now using determinant, or applying the rules of finding the determinant there, you're going to have 1 minus lambda multiplied by 3 minus lambda minus 2 multiplied by 4, and this will be equals to 0. Then you multiply, you're going to have lambda squared, and then that's obtained from minus lambda and minus lambda. And here you have minus 3 lambda, and here you have minus lambda, so you get minus 4 lambda there. And then this, we have minus 8 there. And then, so 1 multiplied by 3. Now, 1 multiplied by 3 is just going to be positive 3, so you have 3 somewhere there, and then this will be equals to 0. Now, you have lambda squared, minus 4 lambda, and then 3 minus 8, that's going to give us minus 5, and you equate that to 0. And this equation can be factorized into minus 4, minus 1. I know that some people have a problem factorizing. So basically here, since the coefficient of this is 1, I'm basically looking for two numbers that multiply to 5 and sum up to minus 4. Now the factors of 5, ignore the sign for now. The factors of 5, it's 5 and 1. And here you just have the coefficient of this to be 1 and 1. So what you're going to do is like write the coefficients there, 1 and 1. Write the factors of this, and you have 5 and 1. Then 1 by 5 it's 5, 1 by 5 it's 5, and 1 by 1 it's 1, 1 by 1 it's 1. So notice that either way, 5 minus 1 will result in minus 4. So that technically means like the factors will basically be 5 and 1. Even if you do it in this case, it's technically going to give you the very same answer nonetheless. And then between so here it's supposed to be minus 5, and here it's supposed to be positive 1. Sorry about that. So now because I can see here it's 5 and 1, there's no 4 here. So now when you get those factors 5 and 1, the bigger number will take this sign here. Between 5 and 1, which one is bigger? it's technically 5, so 5 will take the negative sign. And then you say minus 5 divided by minus 5, then you get positive 1 here. So that means we'll get the eigenvalues of 5 and minus 1. So now you're going to do the same process. If lambda equals minus 1, then you find x1 in terms of x2. If lambda equals minus 1, we can say for lambda equals minus 1, we get, you plug this here, and then you find 2x1 plus 2x2 equals to 0. So this technically implies that x1 is equals to minus x2. So that technically means that our eigenvector will be denoted by something like this. x1 now, it's equals to, okay, let me just write it down. Remember, this is technically the vector here, x1, x2. So we have x1, x2, but now we have expressed x1 in terms of x2, which is just minus x2. And then we have x2, and then we can factor by x2, and then when we do that, we get x2, and we have minus 1 and 1, like that. So if we choose x2 equals 1, then we get that x is the same as minus 1 and 1. So what this technically implies is that for a matrix 1, 2, 4, 3, for a matrix, let me just write it, 1, 4, 2, 3, we have the eigenvector minus 1 and 1. For the eigenvalue of 1, which you multiply by 1 by x, which is technically going to give you x. And then you have minus 1 and 1. And then from then you're just gonna repeat the same process to find for the eigenvalue of 5. So this time you're gonna have 5 there, and you find your vector there, and for the same matrix. So that's just the whole process of finding this out. So just the same process as this one. Express x1 in terms of x2, and then, or x2 in terms of x1, and then choose x1 or x2 equals 1, and then find the values of x1 and x2.